Okay, for this assignment, we were going over a lot of reliable data transfer, and I shall be going through it one by one. This is Comp 4320, assignment number 3. Question 1, problem 1, we're explaining how RTD 3.0 ensures reliable data transfer, and this is a series of how it sends the message, receives an acknowledgement, and then also has a timer related to it. So how it works is if it doesn't receive the acknowledgement in time, that allows it to have not just a send, get an acknowledgement, but a send, then if the acknowledgement is never sent, it knows this within a certain amount of time, and when the timer stops, it sends again. This is a process also uses sequences of 0 and 1. They send a 0 message sequence, and then they receive that 0, send a 1 sequence back in the acknowledgement. That way they can keep going back and forth the same way. For number 2 is congestion control and how it works in general. First, there's 3 parts of it. There's slow start, congestion avoidance, and the fast recovery. Slow start has it slowly exponentially increasing. At first it'll be like 1, then it'll go to 2, and then it'll go up to 4, etc., etc., as it keeps increasing until eventually it finds the threshold, in which case it starts to go 1 packet at a time instead. That is the congestion avoidance. Instead of just keep going at an exponential rate, it finds a very close rate and then slowly goes up 1 by 1 at that point. Fast recovery happens though when there's still errors and problems and there's a timeout or a crash, or in general when it goes all the way back down. Fast recovery starts and it slowly goes back up until about the point where it was, and then starts up back with the congestion avoidance. Go back in and select a repeat are 2 different ways of retransmitting. Going back works by finding the errors, and it'll go 1, 2, 3, 4, 5, and if 3 fails to transmit, has an error, and it'll go everything after 3, 4, 5 when it gets the acknowledgement back. So that way it sends all 5, 3 fails. Since it's in an order, it doesn't want to have to understand the order better for the receiver, because the receiver doesn't have the ability to receive it, usually understand the order. So what it does is it just takes the order again, acknowledges that 3 failed, so it sends 3, 4, 5, and now it just picks up where it was. For selective repeat, only the numbers that failed get resent, but this has a large ado on the bandwidth because it keeps going in the middle of everything else still sending. And the receiver still has to be able to effectively organize everything back together, while the going back has everything in that same order and just picks up where it left off and deletes everything else sort of thing on the way. Going back would definitely be better for more high-speed, low-error networks, because it would only have the 1 error and it would just send everything back again. And because of the high speed, it would be able to quickly go back and forth, because the biggest problem with go back in is just the speed at sending it between them. Problem 2, part 1, explain how TCP ensures reliable data transfer. We talked about the reliable data transmitter 3.0 and how it uses acknowledgements when sending to know that's there, uses retransmissions if it didn't work, and it uses timers in order to see if the acknowledgement came back in time. And if it doesn't, it just resend again just to make sure. Fast retransmit though is very effective at finding this problem and helping make up for the lost packet's efficiency, as it quickly slows all of the transmissions and to help stop the congestion across the network. Because as the network keeps going, all the lines are going up, but then needs to slow everything down once one thing fails, so that way that one can catch back up and fit back into the system of everything. Helps lower the limit, and also doesn't add in a completely new system. Instead, it just has everything else slow down as it fully catches up, instead of having multiple rates. For TCP congestion control and flow control, congestion control is all about having multiple lines go into one and not allowing one line to overtake the others and crash the rest, while flow control is all about having a receiver be able to process everything that it's being given in time, because sometimes the senders can be uploading at a rate that the receiver is not able to process. Both are very useful and are used to prevent full collapse across it, because processor wouldn't be able to have errors in data and have to retake everything else because it can't fully process the order it's given. There are many different reasons, while the other one congestion controls about the network connection itself just failing. Describe the TCP three-way handshake, and why is it necessary? It's necessary because it sends one thing, acknowledges that, and then it acknowledges. This makes both sides show that it has a full connection from both sides sending and receiving, and not just having one side send to the other. This is a full connection all the way through, and it is useful because it just a very simple way of going across all three with only a limited amount of messages. For the TCP connection termination process, there's the force set. It's similar to the three-way handshake where one sends the FIN code, which is the finalized code showing that they're closing. Then it has an acknowledgement sent back by the receiver. The receiver also then sends its own FIN code, and then once it gets an acknowledgement back from the sender, that's the 4 steps. Sends a FIN, sends acknowledgement, sends a FIN, and it sends acknowledgement back. And that both have gotten their FINs and their acknowledgements have been sent, so they both know that they can close. And then both sides close. This has both sides terminate fully at the best way they can. For problem 3, there is the different parts we went over on the graph, and I'm not going to bring up the graph because I'm doing this on the recorded phone, but I will go over my answers. I identified the intervals when TCP was doing a slow start, and that was from the exponential start from 0 up until about 6, so I went 1 to 6. I found out the intervals when the TCP connection avoidance is operating. This was 6:16, where it was a linear line, and also 16 or 17 to 22. And this, once there's after a slight hiccup, there was also a slow start at the very end. I forgot that 23 through 26 for question 1 on that. I'm sorry. Question 3. The 16th round, there's a segment loss, but it does not go all the way down. It only goes to about 24 back down window size. This was a triple ACK and not a timeout because it didn't lose everything. Then there was a timeout though on question 4 at round 22nd as it went all the way back down to 0. Question 5 was the initial value of the SS thresh at the first transmission round being 32. That's just the default. And then the second part of question 5 is what is at the 18th. At 18th, it gets all the way up to about 42 before it has the triple ACK, so it goes down to 21, which is 42 divided by 2. Then question 6, 4 different parts of this one. What is the value of the SS thresh at 24? Since it resets all the way back down to a timeout, the SS thresh is 14. What round is transmission about the 70th segment sent? This was just doing basic math from starting from 0. There was 1, then to 2, there was 3, then to 4, so on. It just keeps exponentially growing. The math found about 8 transmission rounds in. Once it got to about 34, was being 32, somewhere around there being transmitted at a time, as there was the window operating. And then question 6, last part, so when a packet loss detected at 26, what would the receipt, the value be about 3, because it gets up to about 6 or 7, I can't really tell, at the end of 26, and so that would reset and be divided by 2. Question 7, suppose the TCP was Toho instead of Rhino. The triple duplicate, this would have basically the same effects as the other one, except Toho does do it a little differently. When it divides, it goes all the way back down as if it was a timeout. So for number 7, part A of it, it would be the SS thresh would be 23, but the window size would be reset back down to 2 at this point on the window size of 19th, because it went down from 18 to 1, then went back up to 2. And then lastly for number 8, again supposing it resets, we just continue counting up, and I got to about 15. Wait. Yes. Counting from 1 to 3, 4 to 5, etc., etc. Thank you.